Hello and welcome to Nikolai's Genetics Lessons. Today I have prepared one easy problem for you, and here is a problem. If cystic fibrosis is recessive to normal, what are the genotypes of everyone in the family where the mother has cystic fibrosis, the father doesn't, and they have one child who is normal and two children who has cystic fibrosis? And if you think that you can build pedigree of this family and find out genotypes of everyone in this family, I encourage you to take a time, draw a picture, and when you would be ready, you can run video again and you can compare your answer with my answer and explanation. So we know that cystic fibrosis is a recessive genetic disorder, so diploid organism with two alleles can produce three different genotypes. Let's capital A stand for the normal allele, and small a would stand for the recessive allele that cause genetic disorder. So the first genotype, so we have two alleles. So the first genotype would be two normal alleles, and of course this means normal genotype. Second variant can be one normal allele and one recessive allele. Once again, this is going to be still normal phenotype because here we have simple dominance. So when we have one normal allele and one defective allele, and if it is simple dominance, phenotype would be normal. And the third variant would be when we have a person with two recessive alleles, and such a person would be affected with this genetic disorder. And these two genotypes would stand for the normal phenotype. So normal and affected. We know that in this family, mother has cystic fibrosis and the father doesn't have cystic fibrosis. So now we can start building our pedigree of this family, and here is a circle stands for the mother and square stands for the father, and this couple has children. This couple has three children of unspecified sex, so we would use this sign for children of unspecified sex. And we know that mother is affected, so mother belongs to this genotype, small a, small a. And we know that father is unaffected or normal, and that means that he belongs to this group, and his genotype can be this one or this one. But we don't know so far which genotype. But we know that they have three children and one child is affected. So genotype would be small a, small a. And as you understand, one of these alleles this child would get from his mother. It could be this one or this one. But another allele, small allele a, recessive allele, he have to get from his father side. So we now know that father would belong to this genotype. He would be heterozygous and would be capital A, small a genotype. We know that they have two children who is unaffected. So what possible genotype can be for these children we can easily find if we build a Punnett square and list these genotypes of the parents. So let this side be male, whose genotype is heterozygous. He is carrier, but not affected with this genetic disorder. But mother is affected. And now we can predict all the possible genotypes in this family. So capital A, small a, normal phenotype. small a affected phenotype, capital A normal phenotype, and small a affected phenotype. So they would have 50% chances to produce phenotypically normal offspring and 50% chances to produce affected offspring. So as you see, all children who is unaffected would be carriers and would be heterozygous. So these two children who doesn't show any sign of this genetic disorder still would be carriers. They wouldn't be affected just like their father, and they're going to be heterozygous for this genetic disorder, but would be phenotypically normal. And this is all for today. Thank you for your attention. Please subscribe for my new videos that I post almost every day. Thumbs up if you like this video. Please write your comments, questions if you have any, and see you in the next video. Goodbye.